Chapter 2. Imperial and Metric Unit System. Generally, in our construction industry, we followed two measurement units, such as imperial feet-inch and metric millimeter, or centimeter or meter in decimal format, to specify measuring the distance. There are some other units are to follow in any industry which we would like to define as volume, weight, area, surface area, etc. We need to understand both unit format for measuring the distance, how we can measure the distance to get exact length, and in which unit format. It all depends on different countries. In Europe, UK, AUSNES, South Africa and India, they are using metric, and USA, they are using imperial, feet-inch unit format. We can use traditional method for measuring tools to find the length, and following are tools we use for measurement of length, height, width, the ruler and tape. The most traditional way to find measure length using with ruler scale or tape. Also, sometime we need to measure big distance, then other measuring tool, yardstick or folding meter stick. Walking tape measure. You are a surveyor that wants to measure the distance of two separated points on open land. You can use a wheel measure. Simply, we utilize its wheel diameter for the measurement. If the wheel spins 3 times from the first to the end point, and the diameter of the wheel is 1 meter, then the total distance is 3 meters. Laser measure, ultrasonic distance, measurer, with laser pointer. The laser measure offer point and shoot distance measurement. In its most basic form, a laser measure is a handheld electronic device with a digital display. The measure's operator points the device toward an object and activates the laser to receive the distance. There are many more measuring tools which we will use, such as caliper, gauge block, odometer, rangefinder, feeler gauge, altimeter, etc. 2B, F-inch, mm, cm and m meter scale, fraction calculations and unit conversion, 2.4 feet and inch. Following fractional values can be read in decimal format. 1/16 inch equals 0.0625, converted decimal value in inch. 1/8 inch equals 0.125, converted decimal value in inch. 3/16 inch equals 0.1875, converted decimal value in inch. 1/4 inch equals 0.25, converted decimal value in inch. 5/16 inch equals 0.3125, converted decimal value in inch. 3/8 inch equals 0.375, converted decimal value in inch. 7/16 inch equals 0.4375, converted decimal value in inch. 1/2 inch equals 0.50, converted decimal value in inch. 9/16 inch equals 0.5625, converted decimal value in inch. 5/8 inch equals 0.625, converted decimal value in inch. 11/16 inch equals 0.6875, converted decimal value in inch. 3/4 inch equals 0.75, converted decimal value in inch. 13/16 inch equals 0.8125, converted decimal value in inch. 7/8 inch equals 0.875, converted decimal value in inch. 15/16 inch equals 0.9375, converted decimal value in inch. 1 inch equals 1.00, converted decimal value in inch. Now we will check length, width, and height in millimeter/centimeter and meter format. A decimal point is a dot used to separate the whole number part from the fractional part in a decimal number. For example, in 12.34, the decimal point separates 12, the whole number, from 34, the decimal or fractional part. This is a metric length conversion chart that shows the relationship between different units of length millimeters, centimeters, decimeters, meters, and kilometers, using their symbols and equivalent values. Area conversion chart that compares metric units, like square centimeters, square meters, hectares, and square kilometers, with US or imperial units, like square inches, square feet, acres, and square miles, helping us convert between the two systems easily. Volume and capacity conversion chart shows how to convert between metric units, like cubic centimeters, cubic meters, and liters, and U.S. imperial units, like fluid ounces, pints, and gallons, making it easier to compare and measure different volumes across systems. C. Global Local Coordinate Systems. The coordinate system is an input of projection in three directions, such as X, Y, and Z axis. Coordinate system can be considered informed of rotation in Y axis to counterclockwise for X. Axis and Z axis is in 90-degree angle constant. In this global coordinate system, Z axis is always directed upward. End Figure 2, Point 7 to 3-dimensional diagram for global axis. Please refer Figure 2.8, its main global axis, shown in blue color, and offset Shift X and Shift Y indicates with Model X and Model Y direction is local coordinate system, and Fig 2.8a indicate the circular element position in slop indicate the local coordinate system, and if we need to check with 2-dimensional diagram for global axis and model element position, will change as per X, Y, and Z axis. We will understand following things when we work in coordinate and transforming with rotation and scaling the object on elements. Coordinates. We are using points from the XY reference point.